elimination is the third way that we're going to solve systems. So the first way was we graphed them, we looked for where they crossed, etc. Substitution. It was called substitution because you subbed one equation into the other. This third way, our final way, is called elimination. Elimination is where you eliminate one of the variables. Okay? So here's my question. Everybody look up here. If you want to get rid of the number -3, what would you do to the number -3 to get rid of it? Add 3. Okay. If you had 7, what would you do to get rid of it? Subtract 7 or add -7. And that's the whole concept of elimination right there. Is that you are looking for one of the variables to have the same number but opposite signs. So if you have 2x and -2x, what's 2x plus -2x? 0. What's 7x plus -7x? 0, which is what elimination is. You're going to look for one of them to be the same number but opposite signs. Okay, so solving systems by elimination. In cases where the variables in two equations have opposite coefficients, we can solve the system by elimination with the following steps. So first thing you're going to do is you're going to line up the equations to make sure that all the like terms are lined up, which means the x's are above the x's, the y's are above the y's, the equals are above the equals. Then you're going to add the equations together, and that's going to eliminate one of the variables. Now, here's something that you have to make sure, and these notes leave this out, is that you have to sometimes, so this is very important, multiply to get the same number, opposite sign. I don't know why that leaves that out. So what that means is if one of them is a +6, the other one has to be what? -6. So that sometimes you're going to have to multiply to make it -6. If one of them is -10, the other one has to be +10 to cancel out, to eliminate. So everybody should be writing this down right here. This is extremely important. See if I can oh look, my voice. A little bit came back. Once you get one of your variables, you're going to sub it back in. So this would be like what we've been doing. You're going to substitute your answer into one of the original equations to solve for the other variable. And then just like the other one, you're going to write your final answer as an ordered pair and check it. This way is way easier than substitution. So please pay attention. All right, so it says use the method of elimination to solve the system. So this first one right here, what you're going to do is you're going to line up the like terms. Most of the time it's done for you. So this is what it means. Are the x's above the x's? Yes. Are the y's above the y's? Yes. Are the equals above the equals? Yes. Now, what you need to make sure you also check is that sometimes you're going to have to multiply to get the same number opposite sign. So look at the x's. They're not the same number opposite signs, are they? Are the y's the same number opposite signs? Yes. And only one of them has to be. Not both the x and the y, just one of them. So this one's already done for us. They've already set it up to where they're same number opposite signs. So I'm going to move on to step 2. which says add the equations together. Now, here's the important part. You just add vertically. So negative 2x plus 3x is 1x. 4y plus negative 4y is 0. So they eliminate. So I'm going to put an X through them because they're eliminated. They're gone. Yep. And then equals 4 plus 2 is 6. And then you just solve that one-step equation. So divide by 1. You don't have to divide by 1 because it's just the same. But x equals 6. And then I'm going to plug it back in. So I know my answer is going to be 6 comma something. So step 3 says substitute your answer into one of the original equations. It doesn't matter which one. We'll just go with the first one. So I got x equals 6, so I'm going to plug it in for the x. So negative 2 times x, but x is 6, plus 4y equals 4. So that's negative 12 plus 4y equals 4. I'm going to add the 12. So that's 4y equals 16. And divide by 4. So y equals 4. And then I'm not going to make you write them out to check them, but you should check them mentally. I already checked it in the first one because that's the one I used. So we're going to check the second one. So what's 3 times 6? 18. What's negative 4 times 4? Negative 16. And what's 18 plus negative 16? 2. So it's right. All right, let's look at the next one. I really sound awful. All right, so on number 2, I look to make sure it's lined up. So the x's, the y's, the equals, so we're good. All right, so then I look to see if any of them have the same number opposite sign. So I look at the 6's, the x's. Positive 6, negative 6. Yay, they already did it for me. They're already the same number opposite signs. So I'm going to add them together. So 6x plus negative 6x is 0. They eliminate. 2y plus negative 5y is negative 3y. And then 4 plus negative 28 is negative 24. And then I'll divide by negative 3 to get y by itself. So y equals 8. Are there any questions about that step? Like how I got that? All right, I'm going to plug it back in. I'll just choose the first one. It's y equals 8, so it's going in for the y. So 6x plus 2 times y, but we just found that y was 8, equals 4. So that's 6x plus 16 equals 4. Subtract the 16, and then divide by 6. So negative 2. I'm going to check it in the second one. Negative 6 times negative 2, positive 12. Negative 5 times 8 is 40, negative 40. So 12 minus 40, that is negative 28. So it's right. All right, you all try number 3. Franklin, did you already get it? All right, so checking to make sure they're all lined up. X's, Y's, equals. Looking at the X's, they're not the same number, but the Y's are the same number, opposite signs, which is good. So I'm going to go ahead and add them together. So 4x plus 6x is 10x. Negative 7y plus 7y is 0. They eliminate. 47 plus negative 17 is 30. Divide by 10, and x is 3. Everybody good on that? All right, sub it back in. Doesn't matter which one. I'll go with the first one. So 4 times x, but we just said x was 3, minus 7y equals 47. So that's 12 minus 7y equals 47. Subtract the 12 because it's a positive 12. So that's negative 7y equals 35. Divide by negative 7, and y is negative 5. And I can check it. 6 times 3 is 18. 7 times negative 5 is negative 35. And 18 plus negative 35, that is negative 17, so it's right. Are there any questions about if it's already set up for us? Any questions about if the numbers are already same number, opposite signs? Because the back's not. Yeah. Okay, so it says in situations where neither of the variables in the two equations have opposite coefficients. So remember the word coefficient is just the number in front of the variable. It may be necessary to multiply one equation by a constant in order to create the opposite term. So it says when multiplying an equation by a constant, remember to multiply all, I should say all terms within the equation. Okay, so looking at number 5, it's lined up, x's, y's equals. But look at the x's. This is a negative 1 and a positive 2. This is a positive 2 and a positive 3. None of them have the same number, opposite signs. So let's say that Cameron's looking at his and he's like, oh, I want to eliminate the y's. You go, Cameron Cunningham, you go. Okay? Sherman's back there and he's like, no, I want to eliminate the x's. You go, Sherman, you go. It doesn't matter. Okay? It does not matter which one you choose to do. Does anybody have any ideas on which one would be easier? Right, the x. Because look, negative 1, positive 2, they're already different signs. Okay? So if this one is positive 2, what does this one have to be? Negative 2. Does everybody understand? If this one's positive 2, this one has to be negative 2. So is there anything that I can multiply negative 1 by to make it negative 2? 2. Just 2. Positive 2. And here's where it says, remember to multiply all terms within the equation. So I'm going to multiply all 3 of these terms by 2 because I'm just making another equation that's equivalent. Okay, so I'm not changing I'm changing everything, but it's still an equivalent equation. So that'll be negative 2x. 2 times 2y is 4y. And 2 times negative 13 is negative 26. Now when I'm looking at it, I have positive 2x and negative 2x, which means I'm now ready to add them together. So 2 plus negative 2 is 0. They eliminate. 3y plus 4y is 7y. 12 plus negative 26 is negative 14. Divide by 7, and y is negative 2. Now, remember when you go to plug that negative 2 back in, where can you plug it back in at? One of the originals. Okay, one of the originals. Don't ever use the one that you multiplied, because if you made a mistake, you won't catch it. All right, so let's all take a second. Let's plug negative 2 back in to find x. All right, I'm plugging mine in the first one. So I did 2 times negative 2. So that's negative 1x minus 4 equals negative 13. I'm going to add the 4. So negative 1x equals negative 9. Divide by negative 1, and x equals 9. And I'm going to check it. 2 times 9 is 18. 3 times negative 2 is negative 6. 18 plus negative 6, is that 12? Yes, so we're good. All right, let's look at number 6. All right, my x's are lined up. My y's are lined up. My equals are lined up, so we're good to start looking. The x's, they're not the same number. Y's are not the same number. So Blake's looking at it and he's like, I think I'm going to do the y's. But then Brody 1 is looking at it and he's like, no, I'm going to do the x's. Who's right? Both of them. It really does not matter. Okay. Let's take a vote. Who wants to get rid of the x's? Okay, y's. Okay, so if we're going to get rid of the x's, we're going to get rid of the x's. This is positive 4, so this one needs to be negative 4. If you're going to get rid of the y's, this one's negative 5, so this one has to be positive 5. So it's fine either way. Okay, we took a vote. X is 1. Okay, so this is positive 4. We said this has to be negative 4. So what can I multiply negative 2 by to make negative 4? Positive 2. So 2 times negative 2x, that's negative 4x. 2 times negative 5y, that's negative 10y. 2 times negative 29, that's negative 58. And then I'm just going to rewrite the first one above it. I'm not changing the first one. I just rewrote it. Okay, so 4 plus negative 4 is 0. They eliminate it. Negative 1y plus negative 10y is negative 11y. Negative 19 plus negative 58 is negative 77. Divide by negative 11, and y is 7. So it's going to be something 7. All right, now what am I going to do with that 7? Plug it into one of the originals. So I got y is 7, so I'm going to plug it in for y. So 4x minus 1 times 7 equals negative 19. So that's 4x, negative 1 times 7 is negative 7. I'm going to add the 7 and then divide by 4. So I got negative 3, 7. Did you check it? You did. All right, I'm going to check mine. I'm going to check mine. So negative 2 times negative 3 is positive 6. Negative 5 times 7 is the negative 35. And what's 6 minus 35? Bingo, I'm a winner. All right, let's look at 7. Does anybody have any questions? Nobody's really said anything. Anybody? Audrey, I haven't picked up your pencil for a while. All right, so looking at number 7, x's, y's equals, so we're lined up. So looking at the x's, not the same number. Looking at the y's, not the same number. So let's take a vote. Raise your hand if you want to eliminate x. You crazy. Why? Because look at the y's. Anytime that there's a 1 in front of them, it's going to make it easier. So we're going to go with the y's. Since this one's positive 3, this one has to be negative 3. So what can I multiply 1 by? Negative 3. So that'll be positive 9x, negative 3y, and positive 24. All right, you all finish this one. I'll wait. If you're feeling froggy and want to start number 8, you can. Blockage, you get 13x equals 52. All right, so for number 7, when you added them together, you should have got x equals 4. We good on that? I'm going to plug it back in. I'm going to plug it back in the first one. So negative 3 times 4 plus 1y, which is just y, equals negative 8. So that's negative 12 plus y equals negative 8. Add the 12, and y equals 4. So it's a 4, 4. All right, we'll let you all try number 8 all by your lonesome. Looks like we're not going to have time for homework today. But so be looking at number 8. Figure out what you're going to have to multiply by after you choose which variable to eliminate. All right, so what variable are you all choosing to eliminate? Y. Y would be the best. And this one's positive 6, so this one has to be negative 6. So what am I going to multiply negative 3 by? 2. All right, Blake, if you're going to choose X, you said you chose X? Oh, okay. Did anybody choose X? No, okay. All right, so if you are going there, keep going. You better get it right.
It's for my aunt, which gave it to both of her daughters. One out of college, and one is in the
All right, so you should have gotten 7x. 7, I don't know, put one to that. 6y plus negative 6y cancels out. 41 plus negative 6 is 35. Divide by 7, and x is 5. Did we get 5? All right, well, we'll see. We'll see. All right, then you're going to plug 5 back in. I'm going to plug it back in right here for x. So 6 times 5 minus 3y equals negative 3. So that's 30 minus 3y equals negative 3. I'm going to subtract 30. Blake's right. So that's negative 3y equals negative 33. Divide by negative 3, and y is 11. Reckon, were you right? All right, I'm going to check it. Negative 5 times 5 is negative 25. 6 times 11 is 66, and negative 25 plus 66, that is 41. So we're good. We're going to answer this last question at the bottom. Yeah. Okay, so we've had three different ways to solve these now. Okay. It says, explain when you think the method of elimination would be most helpful to solve a system of equations rather than the previous two methods. So when I was solving by graphing, what did we always do to both equations before I could graph them? Well, slope-intercept form. So it's easier to use graphing when they're both in slope-intercept form. So that means they're both y equals mx plus b. Okay? Taryn?
I think I have to answer to the question.
Okay, what do you think about substitution?
I know for elimination.
Okay, hold on. All right, so for substitution, it's easier to use substitution when one of the equations is in slope-intercept form, because one of them is solved for y equals. Right, Taryn, what do you think the answer to elimination is?
Both of them are not in slope-intercept form.
Okay, and I've got a prize for somebody that can answer this question.
What kind of prize?
Food. Okay, listen. Shh. So you got to raise your hand. Taryn is right, but I'm looking for something specific. Taryn says when both of them are not in slope-intercept form, you would use elimination. What is it called when they're not in slope-intercept form? Preston. You want trail mix or crackers?
Ew.
What?
I actually like trails. I like the knockoff.
I'd rather go down to
Hey,
the hill and get
Kate said she'd buy me some actual coats.
Everybody just destroys me.
I'll take them back at you.
Everybody just destroyed me.